Now let's try inductor, one more inductor, maybe two inductors.
Sure. Sure. So maybe two inductors and two capacitors. So something like that. You're going to make it more complicated. More number of.
See, one C and L we have done.
Correct. It gave us S squared.
Yeah.
You'll add one more inductor.
Yeah.
Okay.
Or it could be from a DC source also.
Ah, okay. Sure. Let's do that.
Otherwise, it may be step change.
Step change. Correct. Correct. It will also become difficult for us to do the polynomial, fourth order polynomial.
Yes.
Correct.
So let's say I have a 100-volt source.
Okay.
DC. Then there is a switch. This is going to a 10 ohm resistor and an inductor of 1 Henry. Then again a 10 ohm. So this is 1 RL. That I think we have done.
That we have done.
But initially we were saying RC, multiple.
Okay,
so
correct.
we will do second RL.
Two inductors.
Yeah.
Right. Okay. One more inductor.
One more inductor. So Henry.
Okay.
This is also 10 ohm. So basically there will be two currents.
Correct.
Maybe I1 of t and I2 of t. We'll find out I2 of t.
Sure. Let's do that.
Again, switch is closing at t equal to 0. So there is no initial condition.
Okay. Good. Makes things easier.
Yeah. So we'll just represent in Laplace domain.
Laplace domain. Correct. So that 100 volts in series with a switch will become 100 U of t. No?
100 U of t.
Okay.
So that's by just 100 by S.
That's just 100 by S.
Okay, I'll write it in different color. So this is 100 by S.
Yes, correct.
Because it's U of t.
Correct.
Okay,
and we can remove the switch.
Switch is closed. Resistor anyway no change.
Correct.
This is SL.
SL. So it's just S.
This is also S.
Correct. And these two are 10 ohms.
No change. And this is I1 of S, I2 of S.
Correct.
So basically we will have two equations and then
two unknowns to solve for. Usual mesh analysis.
Correct. So we'll write for the first loop.
Sure.
So when there is a voltage reduction, we take minus, no?
Correct.
So this is minus 10. If I start from here.
Correct. So minus 10 I1 of S.
I1 of S. Then minus
S. I1 of S.
Then here it will be I1 of S minus I2 of S.
Correct. Correct.
Minus 10 I1 of S minus I2 of S.
Correct.
That's equal to
100 by S.
We'll do some rearrangement. So I1 of S into, there is a minus 10 here.
Correct. So it looks like minus 10
So,
minus 11 S.
wait, is this correct? So I have done, this would have been, so.
Oh, sorry. Correct. This is correct.
So is this minus or?
No, this is correct. No, it is 100 by S. This will be.
No, I have taken, if you are going from plus to minus, it's negative.
It's negative.
So,
so you are equating it, you put it in the other side. Correct.
Yeah.
So then it is
So
minus
I
100
think
by
you
S.
didn't notice
I didn't
the
notice that.
Yeah.
Correct.
So there is a negative
sign there. Correct. This is correct.
So everything we can make it positive then.
Correct.
Correct, no?
Correct.
So I1 of S, there is a 10 here.
There is another 10 here.
So that is 20, yeah?
20. So 20 plus S.
Then.
Yeah, correct. Plus 10 into minus I2 of S. So it will be minus 10 I2 of S.
Equal to 100 by S.
Yes.
Okay, this is maybe one equation. Now for the second loop. So again, minus S, I2 of S.
Correct.
Minus 10, I2 of S. Again, minus 10, I2 of S minus I1 of S. Equal to 0.
Correct.
Okay. So there is only one I1 of S. I mean 10 I1 of S.
Correct.
Plus 10.
Plus 10 I1 of S. Minus I2 of, let's see, 10 plus 10, 20. 20 plus S. Correct. So I2 of S has 10, 10, 20 and then plus S. Correct.
Yeah.
Correct.
Yeah. And we want I2 of S.
I2 of S. So we can just write
we'll try
I1.
to eliminate
Yes. Sure.
I1 of S.
Sure. Or we could just, yeah, we could do that. I was thinking we could just write I1 of S in terms of I2 of S here and plug that back in here. But that is probably the same thing because you would have to multiply this by, you want multiply and then subtract. Let's do that.
Yeah.
Let's do that.
So that means I have to multiply 2 by 20 plus S and divide by 10.
Correct. Correct.
Okay. So that will be I1 of S into 20 plus.
Correct.
Minus I2 of S into.
Oh, okay. Yes, correct. Something 20 plus S the whole squared by 10. I can see this is where the second order S squared is coming, no? So 20 plus S into 20 plus S by 10.
Okay. All square by 10.
By 10. This is equal to 0.
So this is third equation.
Third equation.
Now what we will do? 1 minus 3.
We can do 1 minus 3.
That means I1 will go away.
I1 will go away. 1 minus 3 means I2 of S into
this.
Correct.
20 plus S whole square by 10.
By 10 minus 10.
Minus 1 minus 3. Yeah, correct.
Correct.
Minus 10.
This is 100 by S.
Or minus 100. No? No, sorry. 1 minus 3 only.
1 minus 3. So 100 by S.
Okay. We'll copy to the next page because this is
correct.
So maybe we should do some
we can do some reordering.
Yeah. So I2 of S is equal to 100 by S. Divided by, or we should take LCM, no?
Maybe we should take LCM and do it. So we'll get 20 plus S the whole squared.
20 plus S the whole square.
Minus 100.
Because 10 into
10. Correct. And divided by 10.
By 10. So that I can write it here.
You can also write there as 1000 by S. Correct.
1000 by S.
Correct.
So this is 1000 by S into.
So S squared plus 40S plus 300.
Oh, because 400 minus 100. We have to do some.
Correct.
So you are good in applying this trick, no? Means splitting into 2.
Splitting into 2, correct.
So this is.
You know what we could have done? This is 20 plus S whole squared minus 10 squared. So instead of writing like this, we can write this as 20 plus S plus 10 into 20 plus S minus 10.
Okay.
Maybe we can directly write it that way instead of writing it like this. That will work, no? So then I will get 1000 by S into S plus 30 S into S plus 30 into S plus 10. Because all I did is A squared minus B squared is A plus B into A minus B, no? So 100 is 10 squared. So S plus 30 into S plus 10.
Okay.
It's correct, no?
If I had to do here,
okay.
Then that's not obvious. Huh?
It is not obvious.
So this is 2AB is
correct. So I would have done 80. 2AB is
40.
2AB is 40. So then I would have had to factorize it into its these things, no? The roots. I would have done B squared minus 4 into 12. So I would have got the same answer. Correct? So I would have got the same answer.
Yeah.
That is right. I would have got minus 20 plus or minus root of
B squared minus
4AC. Correct. Right.
So that will also work.
It will give you the same answer. Correct.
So this I can.
Yes.
Looks very clean, but we want
Correct.
the I of t.
We want I of t.
So what shall we do? We need to. Okay, last time we have done something, no?
Correct.
We have split this into sum of.
Yes. So what we have done is we have done the sum of individual fractions.
Correct.
We need to do the same thing here.
Okay. So 1000 by S into S plus 30 into S plus 10 is equal to some A1 by this whole thing.
Correct.
Oh, sorry. Plus A2 by S into, I'll just put bracket.
Sure.
Plus A3 by S into
Correct.
So now we need to find out A1, A2, A3.
Correct. 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 So I think in this case you need only individual, no? A1 by S plus A2 by S plus 30
so
into
this
A.
is, I think this is wrong.
Right. So we would just have the individual fractions in the denominator.
So it's A by S.
Correct. Plus A2 by S plus 30.
Yeah. So I will write fresh.
Sure.
A1 by S plus A2 by,
let us say S plus 30.
S plus 30 plus A3 by
S plus 10.
S plus 10. Yeah, that's true. So then what we did, A1 is when
you write it as, you write the expression 1000 by.
Yeah, I'll copy paste.
Correct.
And I think we have made something
correct
hidden.
Yes, we hide that 1 over S, correct. Hide that S in the denominator. And then we set S equal to 0. Correct.
So that will be 1000 by 300.
Correct.
1000 by 300 means
10 by 3. So 3.33.
3.33.
Correct.
A2 means S plus 30. No?
Yeah, correct.
So this we are adding.
And then set S equal to minus 30.
Minus 30.
Correct. So this will give you
minus
20 into minus 30. So that is 600. So 1000 by 600.
1000 by 600.
So 10 by 6, 5 by 3. So 1.67. 1.67.
This is the last one.
That's the last one. Correct.
So here you will set S equal to minus 10.
Minus 10.
So 20 into
minus 10. So 200. So 5. Minus 5. Okay. So maybe we can just write down this expression alone. So I of capital I2 of S.
So this is Laplace inverse of this whole thing.
This whole thing, correct.
A1 is 3.33. This is 1.67.
1.67 minus 5.
Minus 5.
Oh, okay. Now this we know. We have done this before, no?
So 3.33 by S means
is 3.33 U of t. Correct.
U of t will write at the end.
We'll write at the end.
Then here,
when we had 1 by S plus A,
1.67.
Correct. So it was e power minus a t U of t.
Correct.
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 So this would give you e power minus 30 t into 1.67. Correct.
So this is also an exponentially decaying component.
Correct. And then you will
you
have minus 5 e power minus 10t.
Minus 10t. U of t.
Correct. So u of t goes common to everything. Because 1 by s plus a was the Laplace transform of e power minus at u of t. Right? So u of t is common to all functions.
Yes. This many amperes.
Correct. Oh, so this is interesting. So maybe we can do some quick checks, no? So
finally there should be some
3.33. So when t tends to infinity, we need 3.33 amperes. Let's go to the circuit and check. So t tends to infinity means steady state DC, no?
So we are applied a DC voltage.
Correct. And
so
switch has been closed.
Switch is closed.
I am calculating the final value.
So what you're saying is, if I have a DC source and a resistor and an inductor.
Correct.
Vs or L.
Yes.
Then the final value of the current, no? That's what you're saying?
Correct. Well, the way I think of it, final value of current means that I of t is constant. It is not changing. Which means di by dt should be 0. Right? So maybe there is no voltage across the inductor.
Okay. So I of t tending to 0.
Yes.
So there.
No.
Sorry, infinity.
Correct.
Sorry, infinity.
Correct.
Sorry.
If I only have a DC source, I am thinking that I of t should be constant. Because we have solved DC before, no? DC voltage source, you have always assumed that the current is constant.
And then that current will be then just because there is no voltage across this. So this will be Vs by R.
Vs by R. That's what we hope. Shall we check for this circuit?
Yeah.
That is true.
Yeah. So that means there is no voltage here. So I can just short circuit.
Short circuit. Correct.
So I can short circuit this.
Correct.
Short circuit this.
Correct. Let us see.
Will 10, that means it will become 5.
Correct.
So the current through this will be.
So yes. So the current through this will be 100 by 15.
Then we can
and
do
half of that current will flow
go through
this,
that.
Right? So 100 by 30. That is correct. 3.33 amperes.
Oh, okay.
Nice. Nice.
So the other thing, we hope that's correct.
Correct.
Okay. Anyway, this cut etc. I will undo.
Yes. So you're undoing the smiley also. It was nice to have it.
We'll keep it.
No.
At least I want to remove the cut. So this was 100 by 30.
Yes.
That
3.33 amperes. Correct.
Yeah.
Perfect.
Also, but this is very nice.
Yes.
The inductor will be if it's a DC source, then finally the inductor will be a short circuit.
It will be a short circuit. And similarly, we can say, no, if you have a capacitor, it will be an open circuit. So if you have a circuit with capacitors, if you find I of infinity and V of infinity, that should correspond to something where the capacitor is open circuit.
How do you say that?
Because I am thinking that if there is a capacitor, finally the current should be 0.
I have a Vs, then there is an R.
Correct.
Then there's a capacitor.
Correct.
C.
So suppose I have a switch in series with the voltage source and I throw it. Then
Close.
What happens? I close it. Then what happens is current starts flowing. The capacitor starts getting charged. And we have seen this. It is like a 1 minus e power minus t by RC.
That's the voltage across.
That's the voltage across the capacitor. It will be Vs into 1 minus e power minus t by RC. Right. So if I wait for long enough time, Vs comes across the capacitor
So this we have learned from the previous course we have
from the
solved.
previous course.
Okay, okay. So this is BC.
Correct.
Okay. So when t tends to infinity, it will be Vs itself.
It will be Vs itself, which means in
So
steady state,
if I have Vs here, then I of t will be t tending to
infinity. Correct.
infinity. Will be 0.
Correct.
Because both sides I have,
Correct.
both sides of the R we have same voltage.
Correct. So the capacitor is fully charged.
Mhm.
It is now an open circuit.
Mhm. So maybe we should solve some problems
We will.
based on this,
Absolutely, we should. We will.
because you were saying the switch is initially, sorry, open and then it is closed.
Correct.
But the switch could be in a different way also. Maybe initially it is connected to some other source,
Correct. That is true.
maybe a different voltage, and then it is switched to another voltage.
That is true.
Can
Yes.
get complicated.
It can get complicated. Or you could have this switch closed and then opened suddenly, and we can find out how the current
Oh,
or how the
okay.
voltage behaves.
Mhm.
Right? Things like that can also be done. Not in this case,
Hmm.
because in this case you just open the capacitor, just voltage
Yeah.
just stays constant.
Yeah. Ideally it just stays
Ideally,
there.
it just stays there. But we should do problems like this.
Hmm.